Now we will study Huygens principle. What is Huygens principle? It is to construct the next wavefront from a given wavefront. Now, how to do that? Now, suppose this wavefront is given. This wavefront is given. For example 1 and example 2, a spherical wavefront is given. Now, from each point on this wavefront acts like a point source. So there will be many points on this wavefront. So they will behave like point sources. And what does a point source do? So each point source will emit a spherical wavefront. So each point source is going to emit a spherical wavefront. So a spherical wavefront here, a spherical wavefront here, and similarly spherical wavefronts here. Okay. 3. So these are called all backward. Okay. So these are called secondary wavefronts. What is the idea? So the idea is you have one main source of light here, which is called the primary. And so in this case, the primary is at infinity. So this is called the primary source. And the wavefront that it has emitted, this one is called the primary wavefront. And all these points, these are called the secondary source. So they are going to emit a wavefront which is called the secondary wavefront. So these are the secondary wavefront. Sometimes it's called also the wavelet. Now, so once I have done that, then I'm going to point number 3 is all the backward moving wavefronts will be omitted. So we are going to erase all the backward moving wavefront. So here I know in which direction light is going. The third point is that, okay, third we are going to draw the common sort of tangent, but tangent is a line, so it is called actually envelope. So we are going to draw the envelope. So this is my next wavefront. So I hope this is clear. Now, what is important is the proving laws of reflection and laws of refraction by from the Huygens principle. Now, you can look it into the book, so I'm not going to do it here, but I am just going to draw the ray diagram. In the case you cannot prove it, then at least write down the laws and draw the ray diagram. In this case, the how to construct the wavefront. So this is the, in this case of reflection, this is the mirror, and light is coming. So this is the ray of light which is coming. So I can draw the wavefront which is perpendicular to the ray and parallel to each other. Now what I will suggest to you is to first draw the reflected light ray. Okay, and then this will be the new wavefront. Okay, so this is my old wavefront. So I actually need to take these two triangle, this triangle and this triangle, to prove that the angle of incidence is equal to the angle of reflection. So angle of incidence is equal to the angle of reflection. So I'm not going to prove it here. If there is any doubt and anyone wants this proof, you can ask me, I will post it. But for the time being, I'm not proving it here. Okay, what about refraction? Again, this is the surface which separates two medium, mu1 and mu2. Now first draw the incoming light ray, and this is the normal to the surface, and this will be the outgoing light ray. Suppose it is going from a rarer medium to a denser medium. Now what will be the wavefront at this point? This will be the wavefront. And what will be the wavefront here? At this point, this will be the wavefront. Okay. So again, I need to take these two triangles, this, and this, to prove that sin I by sin r, the laws of refraction, sin I by sin r equals to mu2 by mu1. So this is I, this is R. Okay. So if you can do the proof, very good. If you cannot do the proof, at least draw this diagram and write down the laws, write down the two laws. Here in this proof, in the proof of the refraction, there will be an important thing that will come, which is the definition of the refractive index. Now definition of the refractive index is mu2 by mu1 is equals to v1 by v2, where v1 is the velocity of the light in medium 1 and v2 is the velocity of the light in medium 2. So what will be the definition of the refractive index? And these definitions often come that if mu1 is equals to 1, that is air or vacuum, then of course v1 will be equals to c, the velocity of the light. Then mu2 will be equals to c by v2, or we can write as mu equals to c by v. So this is the definition of the refractive index of light.